A very warm welcome to all of you. Myself, Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, course instructor for the NPTEL MOOC course, Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be lecture 16 under the module 7, where we will discuss about the construction equipments, the process involved in the production and laying as well as compaction of bituminous bound courses. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, when it comes to bituminous bound courses, they are widely used in the construction of flexible pavements, specifically under the construction of base courses, bituminous bound courses, which can form as bituminous base courses, bituminous binder courses, and what we have the bituminous wearing courses or surface courses. So, they are widely preferred for construction for the bounded base courses, binder courses and wearing course. So, you can see this is a typical cross section of a flexible pavement where a subgrade course is there, followed by the unbound granular courses under this granular sub-base course, then unbound granular courses for the construction of this is not sub-base, has to be base course. So, unbound base course, a typical example can be wet mix macadam, followed by the construction laying of bituminous base courses, bituminous binder course and bituminous wearing course. So, dense graded bituminous mixes are commonly employed for the construction of these courses, which involves bituminous base, binder and wearing courses. With binder and wearing courses are the top two binder and wearing courses are the one which are laid over a previously constructed bituminous course. And for this particular one, we will be referring MORTH specifications for road and bridge works. We will refer for the guidelines for bituminous macadam IRC 27 2009. One can refer for guidelines for selection, operation and maintenance of hot mix plant, which is used for the construction, which is production of bituminous mixes. Specifications for dense graded bituminous mixes IRC 111 2009. These are some of the codal standards which have been mentioned here. As we mentioned, we will be referring many more than this one while discussing all these aspects. Then this is also one pocket book for road construction equipment IRC 2018. So, when it comes to the bituminous bound courses, as I mentioned, a binder and the wearing courses are the one which are constructed over an existing bituminous course. So, in that case, I can call a binder course is the one which is an intermediate layer between two bituminous courses. So, the binder course primarily functions as the intermediate layer between the bituminous base course and the bituminous wearing course. Now, the Indian codal specifications suggest that what type of dense graded mixes can be used in different courses, specifically in base courses, binder courses and wearing courses. So, the mixes which we have already discussed, dense bituminous macadam, this can be used as a base course, as a binder course or even as an overlay for strengthening, but not as a wearing course. Then semi-dense bituminous concrete used as a wearing course, bituminous concrete also used as a wearing course. There are different gradations of these dense bituminous macadam and bituminous concrete. So, different gradations can be used depending upon where it is getting used and what is the layer thickness. Here it has mentioned this dense bituminous macadam can be constructed in single or multiple layer, bituminous concrete wearing course constructed in single layer, and the typical thicknesses also which can be adopted for these mixes are also mentioned here as per the IRC 111 2009 recommendations. Now, what are the important aspects which has to be looked into while going for the construction of bituminous bound courses? One is one has to look into the preparation of the base where your bituminous bound layer has to come over. So, the existing surface needs to be prepared before you go for the laying for the bituminous bound course. Then depending upon the layer, whether it is an unbound granular layer or it's an existing, because there may be some strengthening exercise, widening exercise is required. So, existing already a surface may be there, bituminous surface is there, over which some bituminous bound layer is to be constructed in that case. So, depending upon what type of existing surface is there, we need to go for an application of a prime coat and tack coat that we will discuss in the upcoming slides. Then the other aspect is the mix needs to be produced. So, the mixing is an important parameter. So, how the mix is getting produced, and then finally it is to be transported. So, for bituminous bound courses, there are standard hot mix plants which are preferred for producing this hot mix asphalt. We will discuss the aspects of different hot mix plants also. So, there we do the mixing, the proportioning of the aggregates and the mixing of the aggregates with the bitumen. So, this particular exercise has to be taken up, and then once they mix, after this proportioning and combination, uniform say mixing as well as coating of the aggregates by binder has taken place, we can see a homogeneous mix has been produced, then it needs to be transported to the actual construction site. There we need to lay it properly, and then compaction and rolling has to be carried out. Finally, a time has to be given, a window has to be given, so as the because they are laid at higher temperatures, so the temperatures comes down before the surface is finally opened for the traffic. So, we will discuss these aspects individually. Now, when it comes to the preparation of the base courses or the preparation of the existing ground to take up any bituminous bound course, it says this work mainly consists of preparing the existing granular, if it is a new construction basically, then, or if there is some major rehabilitation work is there, then granular courses are can come, or otherwise most probably in a new construction definitely over the granular courses you will have to start with the bituminous bound courses. So, this work mainly consists of preparing the existing granular or blacktop surface for laying the bituminous course. Now, in new construction definitely granular courses, some existing pavement, there may be a bituminous course existing. It is to be carried out over the width and lengths shown in the drawings. So, whatever width the is to be prepared, and which is to be prepared as per the drawings which are available. So, that surface or that base has to be prepared up to those particular widths. The existing surface has to be, because why we want to have it, because the existing surface should be firm and clean. There should be no depressions, undulations or some foreign material present on the surface, and shall be treated with a prime coat in case of granular courses, with a tack coat as specified. So, this will be already specified. The surface on which bituminous work is to be laid or bituminous course is to be laid is to be cleaned of all loose and extraneous matter mainly, and what we employ for doing this particular exercise to clean, to remove any foreign material from the surface or any loose material from the surface, we normally go for a mechanical broom or an air jet. So, this is used to clean the existing surface before you go for an application of a prime coat or a tack coat. Any potholes or cracks need to be first properly repaired and sealed. This is an important exercise, that even if there are small cracks are observed or some potholes are there on an existing, if it is an existing pavement where we are putting up a bituminous layer, then those potholes should be filled up with designated proper material, crack should be filled up, and then this overlay exercise has to be taken up. If we are finding that there are lot of depressions, upheaves are there, or a lot of correction has to be required in the profile of that particular existing surface, then a profile correcting course can also be provided. Now, this profile correcting course can be of a mix which can be exactly same as what we are going to put over it, or it may be different depending upon what is the thickness of the profile correcting course which is going to be required. So, a profile correcting course intended to rectify the existing pavement profile, because there may be some depressions, may be there, upheavings may be there, and they may be, if say I am going for a wearing course of a thickness of 40 mm, and there may be in certain cases upheaves may be there of 20 mm, depressions may be there of 20 mm, then at some place the layer thickness, when I am going to meet out the drawings. So, if the existing surface is like this way and I need to maintain a profile, so that may happen in this particular manner. If this goes in this manner, at one place the thickness may be more, at other place the thickness may be less, whereas I need to have a uniform thickness which has been designed. So, in that case I will preferably go for a profile corrective course. Now, depending upon how much is this profile corrective course thickness required, depending upon how much irregularities are there in the surface, we can use the same mix or we need to go for a different mix. Then it may be a binder course in that case, or a profile corrective course. A profile correcting course intended to rectify the existing pavement profile may be provided either as a separate layer or a composite layer of a varying thickness with the same material. When the maximum thickness of the profile correcting course is usually less than 40 mm, it can be laid as an integral part of the overlying layer, when the thickness of the profile correcting course which is required is less than 40 mm. So, once the base has been prepared, any cracks, potholes or profile corrective course requirement has been completed, then we need to go. This is for the application of either a prime coat or a tack coat. Now, for this particular exercise, if specifically when an unbound granular course is there, we will go for an application of a prime coat. So, we will call this application of prime coat as priming. Is the application of what we do is an application of a low viscosity bitumen material to the surface of a non-bituminous granular base course, because we go for a bituminous courses over our granular base courses. So, it is a non-bituminous granular course layer which is to be prepared for a placement of a bituminous layer. So, there what we apply a low viscosity bitumen. And what is the purpose of this low viscosity bitumen to be applied over a granular course is to achieve certain important aspects. What are those aspects? First is so that low viscosity bitumen penetrates the granular course surface and plug any capillary voids which are there. Second is to coat and bound, because these are unbound layers. So, we need to coat and bound loose mineral particles on the granular base course surface. Specifically on the surface, we need to bound those particles which are unbound with this low viscosity bitumen to seal surface pores, and thus another part is we want to seal that particular surface and make the surface of the base course water resistance, because then we have sealed the capillary voids. This will hold the aggregate particles also together, and it will provide a water resistance surface to us. And this will further help us to enhance adhesion between the base and the next bituminous course in conjunction with a tack coat. Normally, if you immediately go for a construction, then the prime coat can serve the purpose. Otherwise, if the application of prime coat thereafter it gets delayed, and when you go for a later stage for an application, then this granular course with a prime coat now becomes as a, you can see this is the application of prime coat which is going on, and this is the IRC 16 which is to be followed, standard specifications and code of practice for prime coat and tack coat. So, once I apply the prime coat over this one, the granular surface becomes to be a surface having a bituminous binder on the top of it. Now, if say after a gap of a period, if now I want to come up with the construction of, it is always preferred to immediately start with the construction, because otherwise other vehicles may come over the surface and damage your surface. So, in that case, if we want to go for a bituminous bound course over an existing course which have been already, where prime coat has been already applied, then we need to go for an application of a top coat. If there is some time gap which is has been passed between the application of prime coat and the application of your any bituminous layer over it. So, this tack coat will now create a bond along with this your prime coat which has been applied over it. In case when existing is already a bituminous surface, you do not need to go for an application of a prime coat, then you prepare the base and you go for an application of tack coat followed by the your next bituminous course. So, you can see this is how the penetration is happening. So, the top capillary voids are sealed, the top surface, the granular particles are holded together, and it makes the surface water resistant also. Now, there is important concern. It should not happen that if if earlier some application has been done few days back of prime coat, and then I need to go for a bituminous layer already, because if time has passed, then this prime coat alone will not serve the purpose. You have to go for an application of tack coat. So, and this tack coat will ensure a bond between the overlying courses and your existing surface which you have prepared with the prime coat. For priming, what we typically use? We use a cationic bitumen immersion. And specifically a slow setting grade 1 SS1 grade is used as per the recommendations or guidelines to be followed in line with IS 8887, or in some cases, specific cases, a medium curing cutback is used as per IS 217 specifications. So, these are the two low viscosity binders which are preferred for the prime coat application, and the quantities are also specified depending upon what type of surface it is. Now, this is as per the requirements of IRC 16 and MORTH. It says if we are having a granular course of wet mix macadam WMM or a waterborne macadam, the requirement of the quantity of this immersion will be around 0.7 to 1 kg per square meter. When it is some different surface, especially mechanically stabilized soil base or lime cement stabilized soil or lime cement base, then this quantity is 0.9 to 1.2 kg per square meter. This needs to be ensured that the proper quantity is getting applied there also. This also needs to be ensured in the field. Now, mainly we go for this spray of or application of a prime coat with tankers which are pressurized sprays there. So, we go for the one which are either the self propelled one or the one which are towed by vehicle, but with pressure spraying mechanism is there with those bitumen tankers. So, manual application is normally not preferred. Only in cases where some specific restrictions are there with related to site, then only some manual pressurized spray can be allowed. So, it says usual quantity of cutback. Now, similarly to what we have the quantities for immersions, slow setting grade SS1 grade for immersions, we have the quantities which have been specified if you are using a cutback bitumen also. For various granular surfaces, even for wet mix macadam and waterborne macadam, and for the mechanically stabilized soil base, lime stabilized soil cement and lime cement base, it says you can use medium curing. The grades are specified MC30, MC70, and the quantities are also specified, that these quantities are to be applied as a prime coat if we are making use of cutbacks, and the grades which are also specified. And as mentioned, the primer distribution shall apply primer at a specified rate. Why these pressurized spray distributors are required? So that the required quantities and the required temperatures are to be controlled. So, this is possible when we have these spray distributors are there. We have the binder tankers with spray distributors, nozzles fitted at the rear end are used. Hand spraying normally is, as mentioned, is spraying with a pressure sprayer is permitted only in case for small or narrow areas where these binder tankers cannot go spray or the binder spreader cannot go. So, there for those narrow areas, say of a width of less than 3 meter, and where the distributor, the binder distributor or the primer distributor cannot go, there we will prefer to go for some manual pressure sprayer which is allowed. The correct quantity of primer should be such that it can be absorbed by the surface without causing any runoff of the excess. This we can see at the edges. If there are excess, it will come to the edges. And to achieve, normally we want to have a penetration of this priming material up to a depth of around 8 to 10 mm. So, whenever this whether it is a slow setting immersion or a medium curing cutback, we want to ensure that the binder penetrates to a depth of around 8 to 10 mm. so that this helps us to ensure what we require from the prime coat in terms of the sealing of the voids, in terms of the holding of the aggregate particles on the top surface and making it water resistant. Now, second comes the application of the tack coat. So, this is tack coat is a light application. Now, this is a light application of low viscosity bituminous material. Again, there is a requirement of a low viscosity bituminous material only applied to existing bituminous. So, if there is an existing surface, it has to go, or cement, concrete or primed granular surfaces. This is also sometimes to ensure bonding, to ensure proper bonding with the overlying courses. It is not intended to penetrate. Now, this particular, as we have the intention in case of priming, application of prime coat, that it penetrates to a depth of 8 to 10 mm. Here there is not as such any requirement. It is just to create a bond between the existing and the overlying courses. So, there is no requirement for any penetration. Already we are considering that the existing surface is impermeable sealed surface. So, it is not intended to penetrate the pavement layer course. So, the application must be very light specifically to provide an effective bond between the layers. That is the only purpose. So, you can see this is an existing bituminous surface over which an application of your tack coat is going on. Now, these are the distributors. These are the distributors with spray nozzles used for distribution of prime coat, priming also used for tack coat application also. In this particular picture, you can again see these are pressurized distributors, and where you can even control with this bitumen tanker, you can control the temperatures also with the openings of the nozzles, with the height of this spray bar, you can control the quantity which is to be carried out. And for this particular one, again trial stretches are constructed, but the trial stretches are constructed at some locations which will be not a part of your this particular project, but very similar surfaces needs to be there, because the trial stretches may not be during these trials may not remain good enough for the actual construction purposes. So, small trial stretches with similar composition can be constructed nearby, where you make these different trials of different applications to ensure for it. So, the binder preferred in case of tack coat, the binder preferred for tack coat is either cationic bitumen immersion, where a rapid setting grade as RS1 is there, because and this is again a thin application is there, complying with IS 8887, or a low viscosity paving bitumen. Even VG10 bitumen is also used in some places for the application of for use as a tack coat, and the VG10 should meet out the requirements of our IS 73 in that case. Or a cutback bitumen, specifically the RC 70 grade is recommended specifically for certain locations, mainly when you have sub-zero temperatures or some emergency applications are there. So, there only the rapid curing cutback are recommended, otherwise it is not recommended. Now, it says paving bitumen is used for tack coat shall be heated to appropriate. That is why these bitumen boilers or spreaders are very important, because they need to be heated up. These VG10 binder needs to be heated up, so that the viscosity is less than 2 poise. So, they have to be brought to a very low viscosity for their application. So, a controlled distribution having a controlled temperature is required through these bitumen distributors for application of a tack coat and prime coat. And the typical application rates which are given for the immersion, specifically for use as a tack coat, is for bituminous surfaces. It says it can go for a range already having in the range of 0.2 to 0.3 kg per square meter. If there is some granular surface which is already treated with the prime coat, so already a prime coat application has been there, a slightly higher quantity, only a slightly higher quantity is used in when granular surfaces are treated with this particular one, prime coat. Now, once the surface is ready, the ground is ready for your bituminous bound layer to come up. Simultaneously, you have to prepare your mix also. So, you have already done a design at at your laboratory, where you have decided the proportions of the different aggregates, you have decided how much amount of bitumen is to be added to it, and the mixing and compaction temperatures needs to be decided, at what temperatures aggregates is to be heated up, at what temperatures binder is to be heated up, and then it needs to be properly mixed. So, there are multiple steps which are involved. One is your aggregate proportioning, which is important. Second is, then you need to dry your aggregates, heat your aggregates. Then you need to add the adequate quantity of binder, which has been already determined from your laboratory mix design, job mix formula, that is to be added. It needs to be properly mixed, all aggregates needs to be adequately coated, a homogeneous mix is to be produced. So, this is now this heating of the drying and heating of the aggregates has to be done at a particular temperature. Simultaneously, the binder, which is again which is to be heated up, brought and added to this particular aggregates, heated aggregates. So, the temperatures at which aggregates and binders needs to be heated up, and then once the mix is produced, it has to be transported to the field. So, what it says involving important aspects related to mixing it, dense graded bituminous mixes are mainly produced in hot mix plant. Now, these multiple functions are done at certain plants, where you are able to control all. As I said, you have to mix different aggregate size, different aggregates into a certain proportion. So, this again has to be a controlled one. So, normally these all steps are done at a hot mix plant. So, it is produced to ensure, or what is the purpose there is to ensure uniform mix with thoroughly coated aggregates. It should not happen that some of the aggregates remain uncoated, or certain aggregates are having more binder film and certain aggregates remains half coated with the bitumen. That should not happen. The table provides the recommended. Now, for this particular one important aspect is the temperatures at which it is to be done. So, some of the recommendations specifically, because a lot of work have been already done, especially with viscosity grade binders or paving grade binders. So, the paving grade binders already some standard on the base of it, some standard mixing and compaction temperatures have been recommended by RC 111 as well as MORTH specifications for different grades. So, it says when one need to prepare mixes, specifically by using the viscosity grades VG 10, 20, 30, one is the temperature at which the bitumen is to be heated, the temperature at which the aggregates need to be heated up, and finally they need to be mixed together. So, what should be the mixed temperature, and once that mixed temperature is there from the plant where the mix is produced, it is taken to the field and there it is laid. So, a laying temperature is also referred, that this should be the laying temperature. And finally, when the compaction is done, there also it is mentions that rolling shall complete before the temperature goes below these temperatures. So, it says rolling must be completed before the mat is bituminous mat. So, we are laying a layer, so we can call it as a bituminous mix mat. So, cools to these minimum temperatures. So, you can see, say for an example, we have a VG 30 binder. So, the bitumen needs to be heated in temperature range of 150 to 165. We have seen these are the temperatures which are there to attain a specific degree of viscosity. When we figured out the mixing and compaction temperatures for different binders, there we have seen that the viscosity should be in the range of 280 plus minus 30 centi-stokes or 170 plus minus 20 centi-stokes for your mixing and compaction temperatures. So, a lower viscosity of 170 plus minus 20 centi-stokes was recommended for specifically neat binders to have those mixing, and then a viscosity of 280 plus minus 20 centi-stokes was recommended for your compaction temperature. So, those compaction temperatures usually comes out for a VG 30 binder in this particular range. So, those temperatures are mentioned here. So, this has been derived from lot of research and experience which have been developed on these binders. So, you can see VG 30, a bitumen temperature in the range of 150 to 165, aggregate temperature slightly higher than what we have for bitumen temperature, and then the mix is to be when these are at these elevated temperatures. By the time mixing should get completed, and once you bring it to the field, so transportation may take some time to actually for the field the mix to come into the field and the laying to start. So, there it says by the time the temperature should not go below 140 degrees centigrade. So, you have a window of around 10 to 15 degrees centigrade. So, you have to take measures that the mix when getting transported to the field, the temperature does not falls very much. So, we can cover those mixes on the tippers while we are transporting the mix to the field. And finally, you have a good number of rollers present with you, synchronized activity, so that you can complete the rolling before the temperature goes below 90 degrees centigrade. So, this gives you an idea that these are the temperatures, and these need to be ensured at the plant also while producing the mix, at the field also while you are doing this laying as well as the rolling operations. Now, this is a typical table recommended given by MORTH and IRC 111 for neat binders, paving grade binders. Now we have nowadays there is a lot of use of modified binders are growing up with the coming new modifiers which are coming up. So, most of the time the modified binders with the use of some polymers or with other substances are having the mixing and compaction temperatures slightly higher than your whatever your neat binders are there. So, either we need to determine those mixing and compaction temperatures by different methodologies are there to estimate those mixing and compaction temperatures. Other way around is most of the time whatever the recommendations which are given by the manufacturer, by the one who the bitumen modification plant people who are giving you those recommended temperatures, they are used in the field because they with the experience with those kind of modified binders, these recommendations are very useful. So, typically the temperatures recommended by manufacturers are followed in case of modified binders. It is also stated that the difference between the binder and aggregate should not be typically more than 14 degrees centigrade, because what happens in the hot mix plant, as soon as the binder comes in contact with the aggregates, it attains, because a very thin film of binder is formed over the aggregates, it attains the same temperature as you have for the aggregates. Now, if those temperatures are very high, higher than what is required specifically, then this will lead to hardening of your binder or aging of your binder. So, it will deteriorate the quality of your binder. So, we will not prefer that the temperatures, the difference between the temperatures are more than, usually we follow to have a temperature difference of around 10 degrees centigrade only. Now, in this particular exercise, while producing the mix at the plant and then taking it to the field, laying it, compacting it, a set of equipments are required. First of all, the one important is your hot mix plant. So, the plant where you are going to produce the mix with the controlled constraints. Controlled constraint means with a mix with a uniform composition and a homogeneous mix. So, this is normally done at a hot mix plant. So, then once it is done there hot mix plant, we can have those ones, specifically tippers can carry it to the field, and then we have these pavers, paver finishers, these are pavers. So, this is your hot mix plant, HMP is there, and this is your paver, asphalt paver is there. This is the tipper which helps you to take the mix from hot mix plant to the site, and then finally you need to do the, once this is laid by the asphalt pavers, you do the compaction by your different kind of rollers which are used for this particular bituminous mix compaction exercises. So, you can see this is an exercise going on. So, we will start a discussion specifically briefly, and this is done for all different kind of mixes, bituminous macadam, dense bituminous macadam, bituminous concrete or any other similar course, say stone matrix asphalt is there. Now, when it comes to a hot mix plant, this forms a very integral part of any bituminous pavement construction. It is a central mixing facility of adequate capacity. The capacity may vary, it can produce mixes up to say, normally the mix capacity is referred in terms of how many tonnage of mixes it can produce per hour. So, how much tonnage of bituminous mix can be produced by that plant in 1 hour is the capacity of that particular plant, and it should be capable of producing hot bituminous mixes with uniform quality and thoroughly coated aggregates. So, this is an important aspect. Now, what that plant specifically, what we want from a hot mix plant is, we want that there is a blending of different aggregate sizes in specified proportions. As we did during the proportioning also, there may be say 4 aggregates you may have to proportion it. So, A, B, C, D in a proportion of say 25, 30, 25 and 20. So, 4 different aggregates in 4 different proportions are to be used for producing the bituminous mix. So, that plant should be capable of doing this particular blending exercise. Drying and heating of aggregates at specified temperatures, because these aggregates may have some natural moisture content which may vary from 2% or 1% or may even go for higher percentages, 3-4% also. So, we need to dry those aggregates, heat and then needed to heat those aggregates. So, there should be a proper provision where this particular exercise can be done. So, the drying and heating of aggregates at a specified temperature, as the previous slide table showed, that those are the temperatures in which the aggregates needs to be heated and binder need to be heated. Uniform heating and addition of binder in specified proportions, at that too at a specified temperature. So, once this uniform heating has been done of the aggregates, all different sizes are to be heated, raised to those standard required temperatures, and then the required quantity of binder again at a specified temperature needs to be added to this one. Then this plant should be able to give you a uniform mixing of aggregates and binder to get a homogeneous mix, and that mix also in a duration where the specified temperature is retained. So, the mixing temperatures is also mentioned, that this should be the mixing temperature where these aggregates and binder needs to be mixed together, though the mixing operation should get completed. And finally, these whatever hot mix plants, they should be safe, environmental friendly. We need to take care that whatever the emissions which are coming out, how they can be controlled to make it environmentally acceptable. And reliable operations, it should be that the variability between your mix quality should not be high, and to ensure accurate and consistent processing. So, for this specifically again certain codal specifications gives you detailed information about the hot mix plant. The one is the guidelines for selection and operation and maintenance of hot mix plant, IRC 90 2010 is there. Then the pocket book for road construction equipment is also there, specifications for bituminous macadam also, which gives information on your the codal specifications related to or the details related to hot mix plant. Now, certain key features which are there of these hot mix plants are, first is a controlled feeding and blending of aggregates in specified proportions. So, you can see we will discuss all these things. These are the cold bins. So, where different sizes of aggregates are put together. So, you can have, if 4 cold bins are there, you can, this can accommodate A, B, C, D. 4 different sizes of aggregates. So, a controlled, and then this there has to be a controlled feeding of this one is required, because I need to proportion, definite proportions of A, B and C and D are required for producing a mix. So, and then once this proportioning is done, these aggregates need to be heated up. So, they need to be first dried up and then heated up to the specified temperature. So, the plant should have that facility where this the drying and heating of the aggregates can take place. Simultaneously, you have these bitumen tankers which are there for a controlled feeding of bitumen, and many a times from the dust collection systems, because the exhaust gases will carry some fines with them. So, we retrieve those dust and they are allowed to re-enter, they are allowed to again entered into your this process, because the fines should not be lost to the environment. It is environmental hazard also. Secondly, it changes your mix composition also. So, whatever the during this especially drying and heating process through the exhaust gases, some fines which goes with them. So, they are trapped, they are again reinserted as per the requirement into the mixing process. So, it says controlled feeding of bitumen and filler in a specified amounts has to be done while this mixing. So, forced mixing of all the components. So, then these all components where fines are there, aggregates of different sizes are there, and the binder is there to produce a consistent, and this should be consistent, because you will require a good, as I said, the tonnages of mix, the capacity may be 100 ton per hour, or it may be more than that, 200 ton per hour. So, that particular one, there should be a consistent homogeneous mix. You will do some regular checks also to ensure the consistency and the homogeneity in the mix, and this is to be produced at a specified temperature, and which meets your job mix formula. The design which you have given at the laboratory should finally met out by the product which is coming out through this hot mix plant. So, this is, and typically two types of hot mix plants are popular. One is a batch type hot mix plant, second is a continuous or drum type hot mix plant. So, we will discuss in the next lecture the details about these different types of batch mix plant, especially hot mix plants, the batch mix type plant and the continuous or drum type hot mix plant. Thank you.